Hey, so in the previous tutorial we were making this table in Blockly and we integrated it into the StackBlitz, and you see that the properties update correctly. We can change the thickness and the height and everything, and the script looked like this, and it's quite important because in TypeScript we will create a similar looking logic. It's going to be a bit different, but in principle the essence will be the same. So let's go ahead into our Bitbybit dev platform. Let's hit this apps button, open Monaco, and start coding. So first thing we'll do, we will define a type of inputs, and you remember that we had width, that was a number, length, that was a number, a height, that was a number, and thickness, also a number, right? Okay, so now we will say that we have default inputs, and that will have a type of inputs as well. So width will be 1. Yeah, we need assignment. So length will be 1.5, height will be 0.5, and thickness will be 0.05. This is quite nice. Now we can inform bit to mock these inputs, and we'll use default inputs. So now another thing is we will get those inputs as inputs as well, and we will use get bit-by-bit runner inputs command like this. So now we just get the inputs that will be default from the mock, because we're in this Monaco editor, and when you will be executing this code from the runner, it will just give you different values that you pass into the script. So another thing that we do usually is we create this start function, which is asynchronous, and we will do it again like this. We'll say that we have runner outputs that are assigned to whatever comes from the start function, and we also need to define some constants that we will use. So we will use a solid, compound, and face. All of these come from Bitbybit OCCT shapes category. So now that we have this setup, we will go ahead and derive some variables from the original inputs that are useful for our code. So let's do that. Let's define the leg height, and I guess you know how to compute that. It's inputs.height minus inputs.thickness, right? So the leg needs to go towards the tabletop, but it needs to hit its bottom, and that's it. So leg height reflects that. Then we have a half leg height, and you'll see later why we need that. So we'll see that this is just divided by 2. Then we also need half thickness, and that's gonna be inputs.thickness divided by 2. And we need width offset. This will be used for leg positioning, and we'll see that this is just inputs.width divided by 2 minus half thickness. And then the length offset will be inputs.length divided by 2 and minus half thickness as well. Okay, so now we have our intermediary variable setup. This is just to save us some typing in the future. First thing we will do is create the skybox. So we will go into the Babylon scene, enable skybox. So enable skybox has these inputs that it expects, and we will just say that we have the skybox options object like this, and we'll instantiate a new class, and we'll say that the skybox options skybox will be the value that comes from the enum. So it's gonna be clear sky, and we'll pass along these options to this method. So if we hit run, now you'll see that we have this skybox that we always use, and we can go back into the editor and continue typing. Another thing we'll use is the directional light. So Babylon scene, draw directional light, and this requires also some options. So we say that we have here light options object, and it's new. And the only thing that will change here is the intensity, which will be 3, and we'll pass along these options to this method. Okay, this is done, and now we can begin coding our table. So to do that, we'll start with the table top, and we'll use this solid constant to create a box. And we'll say that our width of the table is inputs.width. Our length will be also coming from inputs, and the height will be coming from inputs.thickness. The center of the tabletop will be 0, and then the height where this tabletop will be positioned will be inputs.height minus half thickness, and then 0. So this is quite logical, I hope. I'll name this constant table shape just in case, and I'll draw it now on the screen. So let's do it like this. Let's attach this table shape to the entity, and also let's maybe draw a grid so that we know better where this tabletop is positioned. So I'll do it like this, draw grid mesh, and these options need to be used, so let's just do it like this directly. Let's instantiate this class, and let's hit run. So now you see that the table top is created. It's hanging in the correct position. Its width is correct and its length is correct, and we can go ahead and code the legs. So the legs will be coded a little bit different than we did in previous tutorials, and it's due to the fact that here we can just create the boxes more easily, maybe without translating them in correct positions. So I'll just say create box again. The width of the leg will be inputs.thickness, right? We have length of the table, which will also be inputs.thickness, and then the height will be leg height. And then the center, well, the center for the first leg will be width offset, then we'll say a half leg height, and length offset. So this is our center point. Yeah, we have to fix this. And now we can draw a leg shape instead of the tabletop. And you see that it does exist somewhere in space. Just to make it a bit easier to comprehend, we'll create a compound shape of everything that we create, and we'll do it like this. So we'll say compound, make compound shapes, and then we pass table shape and leg one shape. And I'll just rename this table shape to tabletop shape, right? This is just the correct way to do it. So now I also say to this draw any async method that I need to draw this compound shape, and I also need to await on this method. So let's hit run, and you see that now I have a tabletop on the screen and I have one leg. So this is not too much, but I just need to create 3 more legs and a ground. So let's do that. I'll do it in a simple way. I'll just go ahead and copy paste this code 4 times. I'll say that I have leg 2, leg 3, and leg 4, and I'll use minus width offset, minus length offset here, minus width offset here, and minus length offset here. And this will do the trick. It's quite simple math, right? So let's go ahead and add these legs to this array. Okay, and now let's hit run, and you see that we have our table set up correctly. The last thing I'll add is the ground. So let's create the ground from the face of the circle, and let's do that by saying ground shape is await face, create circle face, and let's say that the radius will be 2, center will be on 0, 0, 0, and direction will be on 0, 1, 0. Okay, let's include the ground shape here, and let's hit run. And you see that now we have our table set up in the correct way. Now that we have this, we can go back here and we can optimize how we draw this. We can say that we use some options, right? And we will use some simple options. So let's make them like this. Draw options is new, bit, inputs, draw, and then draw shape simple options. And we'll say that we want to use a color for the face by defining like this. We will use the edge width of 1, and I'll do draw options like this. So now we have here a table. We will await and we'll return it like this in the object from the start method. So let's hit run. You see that we now have this nice looking table with white lines on the edges. We will remove the grid that we've created in the previous step. So let's get rid of it. Now that we have this, we just need to return this to the runner, and we'll do it like this. So bit set Bitbybit runner result, and we'll use the runner output like this. And I think we're done. So we can try and just integrate this code via export to runner command. We can minify it to make it really small. And we go here, we select this old Blockly code, we remove it, and we paste the new code from TypeScript. And you see that it just looks exactly the same. We can change these inputs to change the size of the table. Can make it smaller or higher. We can also change the thickness, and everything adapts as we expect. So this works. And another way that we can do it is, instead of using this inline script, I can just say that I want to code it directly. So I will create here few variables bit by bit, and then bit. In this runner method run, I will say that I expect to get the result, and I will assign bit by bit to res.bitbybit, and I will assign bit to res.bit. So now we have these, we define them, and we can just go ahead into the TypeScript code now, hit export to runner. We will be taking these things without all the boilerplate. We'll save, go back to here, and I'll just paste all of that code in here. So here we will need to say that constant res is whatever comes from the start. Also here I'm going to define inputs as being the model, and that's it. Now the whole configurator that we coded in TypeScript on the Monaco editor exists here directly, not loaded via the inline script, but you see that you can now just go ahead and directly change the code if you want to. So make that ground larger, for example, if you want to, or do some other things in here directly. So I hope you guys enjoyed this tutorial. I hope you understand now how Read editor, Blockly editor, and both TypeScript editor can be used to code exactly the same table 3D configurator, and how to use our export to runner functions to integrate everything in your own websites. So if you enjoyed these videos, just subscribe to our channel and give us a like, and let's see each other in the next videos. Cheers!